Okay, kia ora, good evening everyone, and welcome to our last Café Scientifique of the year. There's only a couple of us online at the moment, but hopefully some more will join us shortly. Thank you everyone for joining us online. I know it was a bit of a surprise to need to change venue, but we needed to do that for a couple of reasons, and it's actually worked out somewhat in our advantage in the end. So this is our last one of the year, and it's most likely going to be my last one as the convener of the Café Scientifique. My term with the Auckland Museum Institute ends at the AGM, which is on the 15th of November. Yes, so I will still be involved in the cafe in the future, but I'm going to be taking much more of a behind the scenes role, and so the people who are going to take care of you in the future are going to be Marilyn Colhassie and Moss Sutherland Tupp, who you will probably have met in one capacity or another at the cafes before. So of course tonight we have Pete Brooks from Auckland Council giving us an overview of stormwater environmental enhancement projects, which is going to start in just a minute. But I just want to bring to your attention a couple of the other events that we have coming up before the end of the year. So next week we have the Lucy Cranwell lecture, which is much delayed. Originally it was going to have to it was supposed to happen last year, and of course was moved because of COVID, which we're sad about, but happy that we've managed to get it now. So we've got this year's Lucy Cranwell lecture is give me 1 second, sorry, is on urban ecology by Dr. Colin Merck, and so that's going to be on Tuesday in the museum auditorium up at Auckland Museum. Tickets are available online. If you're a Museum Institute member, you can also just turn up and they'll book you in there. The other thing that's coming up on the 22nd of November is our last conversazione for the year. Dr. Hugh Grenfell, who is a Auckland Museum Institute member, is going to be talking about the building stones of the Auckland Museum and their geological stories. Also next month at the AGM, our keynote is the Global Biodiversity Facility by Dr. Yumiko Baba, who is the Associate Curator of Botany at Auckland Museum. So those are some 3 great events that are coming up in the next month. And of course, the Café Scientifique will be back next year. This is also where I have some more bad news. So in next year, there aren't going to be as many cafes. We're going to reduce the number. So instead of having 8 or 9 in a year, there's going to be closer to 4 or 5. And that's in no small part due to the impacts that COVID has had and making it harder to run events and harder for people to come to our events. So we're hoping that by running a few less of them, more people will be able to come and we'll be able to run other events as well. But more details will come out next year when the programming is all finalized and lined up. So keep an eye out. If you're a Museum Institute member, keep an eye out on the newsletters. They'll come out to you by email. And of course, you can follow us on social media and get everything there. Right, that's it, admin covered. Hopefully some more people will come online momentarily. In the meantime, of course, we are recording this, so this can go up on YouTube probably next week or the week after. So yeah, I don't need to do any other further introductions because presumably you've all already read the blurb. So right now I'll just hand over to Pete, who will take it from here. The format for tonight, realized I forgot to mention, the format for tonight is Pete is going to talk to us for 15-20 minutes. He's got a video for us to play as well, for us to watch. He's going to play, we're going to watch it. Then we're going to pause for a break so that Pete can have rest his voice for a little bit, have something to drink. If you've got any questions, pop them down into the chat below. We've already had a couple of messages in the chat, so you can add your questions in there, and then I'll collect them together and read them to Pete as we go. So without further ado, thank you, Pete.
Kia ora, thank you, Scott. That's great. What I will do is just share my screen, so give me one moment. Tēnā koutou, ko Skiro te manga, ko Trent te awa, ko ainga te iwi te whānau, if whānau e mā he Nottingham, ai tupu ake a lista, ko Ngati Pakeha te iwi, ko Tony te raro, ko Velrine ako mata, ko Pete Tokuingawa, nō reira tēnā koutou katoa. As Scott has beautifully put, and we have a bit of a format for this evening. I'm just going to stop my camera so you don't have to see me in the corner if you're there. Just a bit of a background on why and what Auckland Council Healthy Waters Department does. Safe Swim is one of our key flagship projects. A couple of projects we're going to take you through is actually around the naturalisation of streams. As Scott has already alluded, a bit of a time-lapse video, a quick break, and a discussion and questions. I can talk for an hour and a half. I'd rather not. Really challenging questions, conversations are even better. So yeah, let's see where we go from here. So Auckland Council have a product called Safe Swim. Some of you may or may not have heard of it. Safe Swim ultimately is a collaborative program providing a real-time advice of the level of risk associated with swimming around locations in Auckland. It's a partnership between some really key organisations in Auckland, and they're doing a really great job. And this is spreading beyond Auckland as we speak as well, because there is real opportunity to see what's going on and why, to combine the understanding of data across the wastewater, which is obviously owned and managed by Watercare, and the Stormwater network, which is owned and managed by Auckland Council. Directly, there's a department within Auckland Council called Healthy Waters that has a specific target of actually trying to improve the water quality in our harbour, and have been working on this for the best part of 5 years specifically, but obviously longer term over that. We use predictive modelling to do that, which is a really clever piece of software that actually looks at all the weather patterns, the tidal patterns, sea temperature aspects right the way through. And all of this is actually underpinned by real, regular actual sampling on the beaches. So we send people to each of these sites and actually test them. We monitor at present 210 sites with over 120 stations on Safe Swim. This is an overview view of Auckland. If you went to the Safe Swim site, there's the web address at the top if you're interested, and actually you can drill right down into individual items for each of those locations. So it's a great way to actually understand what's going on in the city and why. Why am I telling you this? Well, everything we do, I used to be in Healthy Waters, I'm not anymore, but everything we do at Auckland Council around the water quality is really based around ensuring the harbour health and actually making sure that grows and continues to be the product it should be, and actually the amenity that everyone can use. So I'm going to talk to you about a couple of projects. These are stormwater ponds, and we worked very closely with Glasgow contractors, and I'm eternally grateful for their involvement in this. And they may be joining us later or not, but they've certainly got an invite. But if they do, you'll get a contractor's view of how much of a tyrant I am. I was the engineer to contract on both of these projects, and I managed the team that actually designed and led the project from its inception right the way through to completion. So Unsworth Reserve will be the first project I'll take you through. Unsworth is on the north shore of Auckland, just to the west of the Upper Harbour and Constellation Drive on-ramp. And in this reserve, we have 3 ponds, an upper pond, a middle pond, and a lower dry pond. The flow of water goes from south to north, and what we're actually looking to do is improve these facilities, because they were built circa late 60s, early 70s. Engineering wise, they were there to protect the environment and slow the flow of water. and they weren't functioning particularly well. There are a number of reasons for that, which I'll come to later. But what we wanted to really do was provide and improve water quality treatment and attenuation. So actually keep the water away from the harbour for as long as we can, and so that allows us to treat it more effectively. The first thing we did was actually desilt the actual ponds themselves. So the photo on the left is at what's known as a truck saw. It's an amphibious desilting machine. Basically, it's a big hoover with a digger bucket on the front for the non-technical, and what that does is actually the hose pumps the silt from the bottom of the pond, which has been disturbed by the digger bucket. That goes through some flocculation and chemical treatment that basically captures all the solids. It then goes through a bagged filter where it catches the majority of the solids that are flocculated out, and the water is actually returned back to the natural environment, which is tested on a daily basis. Once that's actually completed, we dug out the bottom of the pond, and as you can see through the middle of it, there is a channel. That was the original stream bed. These ponds were built on an original stream, and that led to some issues, which I'll come to further on in the presentation. But we weren't expecting to find a stream bed, and the ground conditions with that were quite challenging. And to the right, what you're seeing is actually starting to mark out the ultimate changing of one of these ponds into an actual wetland to improve that water quality and treatment. Once we actually worked out the base of the pond and dealt with that stream bed by actually removing a lot of the material and compacting it, we had to bring in material to build up a purpose-built wetland. So yeah, it's a significant amount of soil, significant amount of rock, to make sure that the base of the pond is secure, and we worked through that extensively, causing quite some disruption to the local reserve itself, but the locals got used to it, and we reinstated it completely afterwards. Once that was complete, so this is the same pond in the top left-hand photo is actually looking down, looking north, and in my original map, actually showed that the little lakes are actually deep areas of water. I don't know which you know about ponds and lakes, but wetlands particularly, but you actually want deep water for fish life and micro invertebrates to live, so they actually can breed and do everything they need to do, and we actually purpose built that in. We had to significantly compact the material in the base of the pond to be sure that it doesn't wash away. That's the photo to the left. This is we also had a stream bed we needed to reinforce and protect, and this is actually doing that work. So we're using concrete matting and significant rock, and we went on to build a huge amount of rock, brought a huge amount of rock into this reserve. The photo to the right is just a general photo around the rocks and how we actually place them in the local reserve. Minimal impact as much as we can. That's pretty much Unsworth. So as you can see, we've got that the original photo is on the left, so that's a swamp cypress in the pond. That was causing us some significant problems, and the photo to the right is actually the naturalized wetland. It's a ecosystem in its own right, and it's doing a beautiful job in actually treating that water quality and making sure the water that enters the harbour is better for everybody. Number of challenges for this project. The swamp cypress, as I alluded to, the problem with it as it's actually quite a specimen tree. It was a weed. We did get consent to remove it, and we had some challenges with the local community and local board around wanting to keep it. It was taking up a significant amount of surface area within the pond itself. As you can see, we really need that treatment. It's a limited site in a particularly urban area. We actually removed a significant amount more silt than we actually estimated originally, and that was due to the pond actually being deeper than we actually estimated. All of the records that we used for the original design were taken from the drawings from North Shore Council as it was then. It's probably actually the local council prior to the North Shore Council being formed, and let's just say they didn't have the detail we were expecting, and we assumed there was actually a pond liner in the base of the pond, and there wasn't. So we actually had to remove more silt because it just kept going because the North Shore clay dissolved. The channel, as I've already alluded to, caused us some problems. So all of this basically meant we had to bring more rock, clay and topsoil to actually build that wetland to make sure it was to the right levels and functioned accordingly. All of this caused significant cost implications, and we actually required an additional resource consent for the dry pond works. That's Unsworth. Here is a slightly different project, but in a very similar vein. This is actually a naturalisation of an area. Again, North Shore, more towards Browns Bay. So this is just above Browns Bay off Glencoe Road, if any of you know Browns Bay well. Bit of an artistic impression of what we were looking to do, how we were looking to do it, and actually made sure we can take things forward. Huge opportunities in this reserve, and we've actually achieved most of these, to be perfectly honest. I'm not going to go through line by line, but it's a significant catchment actually drained into the area. We actually removed a pipe and actually restored a natural stream to the area. And the real key for me personally is actually reintroducing that fish passage to ensure the fish can get back up into the higher echelons of the catchment, because they bring so much opportunity to the environment and the actual whole ecosystem. Some challenges along this one in various ways. Again, bit of an overview, so I'll start from left to right. So it actually goes west to east in this case, so it's flowing towards the east coast bays. At the top left-hand bottom corner, sorry, the bottom left-hand corner at the top, that's where we removed a concrete channel and we naturalized that stream. The forebay is the next area. This is a purpose-built area where we actually look to capture silt to prevent it entering the wetland, which is the next phase. The wetland is there to actually cleanse the water and actually allow the oxygenation and all sorts of ecological processes to take place. And then we actually removed 90 meters of actual concrete pipe, which we used for a sign later on. And then we reinstated a lot of the riparian margin further down below because erosion was a significant issue. We're really keen in this kind of a project to actually engage with the local community and the schools. We worked very closely with all three of the schools listed. That included actually coming and operating diggers. They were there when we removed a significant number of pine trees, and it really helped bring the children into the environment and actually help them understand that, you know, a lot of what we do isn't by accident. Yeah, this was a project that took over 2 years to design. It's made a massive ecological significance and an improvement to the area. The construction techniques are quite unique, and I absolutely commend Glasgow's for actually working with us and actually really wanting to think this through. And we had to adapt right the way through this. I do have to know both of these projects were built through COVID, which brought their own challenges, and we had a number of site visits with the kids, so it's been a real win all around. Just some very quick photos through this. So the top left-hand photo is the stream before we started. So it's a concrete channel. As you can see, there is iron through it. Iron and manganese, that's what gives it the orange color. That's a really particularly interesting bridge that was over the stream at the time, which we completely replaced, working with our parks colleagues. The bottom left photo is actually the start of the process and actually how we naturalized the stream. So actually starting to put meanders and bluffs into it with rock ripples, coconut matting for planting. And the bottom right is actually the new bridge in, the planting starting to establish itself. Forebay, as I've already alluded to, the forebay is there to actually just de-accelerate the water, which allows the sediments to drop out, and then what it actually deliberately drops out in this location, and then what we can do is come back once it's filled. We target every 5 years to actually come in and remove that silt. The photos in order, so top left is before we started again. As you can see, it's significantly clogged. It's not actually operating as a forebay, and we removed all that planting, all that vegetation, redug the base of the forebay. Again, no pond liner, which caused significant issues. We removed a huge amount of silt from this site, and the photo on the right is actually the completed works at that site. And that you actually see the bottom of the forebay, which in my experience, we hadn't even seen, beyond the top couple of mils, let alone the bottom of the actual pond, which is a real achievement. As I've already alluded to, the wetland is purpose built, it's bespoke. Again, top left is before we started, so you got a floating wetland, which was a maintenance challenge, and trying to get men onto that to maintain planting that didn't particularly like being there, didn't particularly work, didn't add the ecological value we wanted, had significant botulism, avian botulism issues around people feeding ducks bread, and basically what they do is they die and they sink to the bottom of the pond, and they just end up, it's a vicious cycle. There was a weir, which you can just see in the very bottom of that top left-hand photo, which completely prevented fish passaging up. The fact that we got a grass or a piped network beyond that, absolutely compounded that. The bottom left-hand photo is the work in progress. Again, deep area of water, and we put a boardwalk through the centre of it, and the two right-hand photos gives you an idea of what we did and how we did it. There's a boardwalk runs right through this as we speak. Coming back to that fish passage piece, as you can see, that top left-hand photo again is before we started. There's absolutely no way fish were going to actually make their way up that slope. It was designed so they could, and we did get a reasonable number of fish out of the forebay and the pond, but most of them were koi carp, and there were a few eels, but we had to isolate the pond and drain it for construction reasons after we'd done a lot of the work, and we'd reconnected the fish passage, and we ended up removing 28 eels, and they had actually established themselves in a minimal of time. It's probably only about 6 months, so that was the idea. The bottom left-hand photo is how we constructed the fish passage. So what we actually created was a number of boxes interlinked with minimal height jump. So a lot of the native fish can't jump very high, so they're actually only 50 millimeters is the maximum height they can jump. So we actually worked around actually solving that, and that's why it is so long and convoluted, but it's actually really a nice feature. It's a wonderful sound. If you ever get the chance to go and have a look, it's incredible. And the two right-hand photos again are the actual project completed. We deliberately built a viewing platform actually to try and help people connect with the environment itself. Daylighting the stream, as I say, this is the 90 meters of pipe, so we took that grassy, muddy slot of land that was low-lying that we overflowed, created a naturalized stream. So the right-hand photo is the work in progress. You can see the fish ladder has gone in, but there's no planting or naturalization been done. And the bottom left-hand photo is actually the completed works again, and that stream runs permanently. Challenges for this project. Again, as we've already assumed, the top pond was built as a forebay, which it actually wasn't. We ended up removing an additional 3,000 cubic meters at the cost of over $1.1 million alone for this project. COVID lockdowns throughout all of it, which was brutal, and our contractors worked so hard, and actually, were back on site as soon as they could be. But equally, we had next to no time to actually make this site safe and ensure that it was secure while we were all locked up at home. We actually had lost the project manager for this job due to them being a contractor, as an impact of the Auckland Council emergency budget, which would cause significant issues in actually continuity for the actual understanding. I was still the engineer, but actually people running on a day-to-day basis changed. Excuse me. And the removal of the concrete channel created a real challenge that I hadn't actually thought of. And this is all good learning, but it's really around, we remove the concrete channels that gives us the right thing to do. Excuse me, I'm just going to cough. Sorry about that. Removal of that concrete channel, we removed the weight, and what that caused was the slopes to move, and we ended up having to build an in-ground wall to prevent that rotating. Hadn't actually thought about that prior to, so the lesson learned is actually just leave the concrete in place and design your levels around the new height, because it creates a significant number of issues. Excuse me. Time-lapse video. I shall see if we can make this work. So here we go. So we're starting at the top end of the project. That's removal of the concrete channel. That's the actual slope that failed. Just working through naturalizing the angles, actually introducing flow. Some matting to actually protect the sides is going in. Bit of a root wad, which is just a tree trunk, but fish and invertebrates really like it. Actually enhances the whole environment. Coconut matting to prevent weed growth, but that's all without plastic, which is really cool. So again, it doesn't create microplastics. Removal of the silt and creation of a new path down the left-hand side of the stream. Concrete path, 3 meters wide. Nice access track for future maintenance. This is the fish passage going in, as you'll see on the bottom left-hand side. Here it comes. Really clever construction method. We had to make it as light as possible, and Kate can talk to some of that later maybe. But I was really impressed at this. This works so well. Looks so simple when it's done, but the angles and the heights was really a challenge to get right. It's starting to get a naturalized stream and a bit of a pond. This is the actual desilting of the pond. We've got the floating wetland still there, so they're actually taking the sediments out, dewatering it, more sediment coming out. See the boom across to protect it, making the pond significantly bigger so the wetland can actually function properly. Creation of the deeper bits. Route for the board walk through the middle. Soil going in again for that base so the plants grow well. Planting in as early as we could. We were up against the time of year because plants don't like to be planted in summer, and so we had to really up against it even in these conditions. Boardwalks starting to go in. Beautiful boardwalk, great piece of work. Plantings coming on, and this is the drone footage from the end of it. I'm just gonna let you enjoy. It's almost like it's always been there, and even now it's phenomenal. They actually do a park run through this reserve now, and we actually brought a whole level of amenity we never even thought of, and the guy who runs the park run's been phenomenal. He's been so appreciative of what we've done. We're changing, we built this project to deal with the water quality at Browns Bay Beach and the fact that it was failing on Safe Swim year after year, but the outcome of the actual other stuff is significant in that space. Stop share. So that's it from as far as the presentation goes.
Excellent. Well, thank you both very much. If everyone can, from wherever you are in the country, give them a thank you round of applause, and to just give a little end to the talk. Thank you everyone for coming. Thank you for supporting the Café Scientifique this year. It's been a little all over the place, as it has been the last couple of years with COVID and things. And so, yes, so this is the last one for the year. Next year, we'll probably have a new MC. He will be way more fabulous than me. It'll probably either be Marilyn or Moth, but I'll still be coming around, and so we can say hi and stuff. And don't forget, there are still a few more events between now with the Museum Institute between now and the end of the year. Next week we have the 2022 Lucy Cranwell Lecture, Urban Ecology with Dr. Colin Merck from Manaki Whenua Land Care Research. Later in the month, we have the Building Stones of the Auckland Museum, their geological stories, Dr. Hugh Grenfell from who's one of our members, and that's going to be on the 22nd up at Auckland Museum. And of course, on the 15th, just the Tuesday before that, we have Yumiko Baba, who's the Associate Curator Botany for Auckland Museum, giving the keynote at our AGM, talking about the Global Biodiversity Facility. And that's takes us out to the end of the year. So thank you very much, everybody, and have a wonderful evening.
Thank you all.